My name is Evan, and I go to Menlo Atherton High School. And for my project, I made this custom designed audio stomp box that you can use for any electric instrument like electric guitar or keyboard or synth or even a microphone, though I haven't tested that one yet. I chose this project because you can buy stuff like this online, but it's expensive, and it's not like you can buy maybe one kind of effect at a time. Like if you wanted this one sound, you'd have to buy that thing. But this one is fully programmable, and I can make it do whatever I want, and I don't have to spend any money, so that's nice. So I'll give you a quick demo over here. So right now I have just this virtual keyboard set up on my Mac, so I can play some sounds, and then if I wanted to add effects, I could do that with my unit. So I can make it do this little sound, or I can make it sound more distorted if I wanted, if I do this. Or I can add delay, where it would sound more like this. So you can see the sound just kind of repeats. And the idea is I can just make it do whatever I want. So if I wanted something else, I could just upload some new code that I wrote. This project had a lot of challenges. My first thing that I ran into was the fact that a lot of different instruments use different types of signals. Like for example, something coming out of a computer port is a pretty easy signal to read, but something coming out of like an electric guitar, for example, is kind of in a different format. So I had to design this custom PCB that could kind of understand all the types and convert it into a format that my microcontroller in here, the TNC 4.1, could read and process. And along the way, I had a bunch of other problems like hardware burning up. I burned a bunch of potentiometers while soldering due to the poor heat tolerance. And I had a bunch of stuff not work. Like the screen, for some reason, when I first installed it, was slightly offset, so I had to fix that in software. But overall, it worked out pretty well. I designed this custom 3D printed enclosure for my third milestone, and that holds everything in there. I added some vents for cooling, and I added these output jacks so you can put in these 1/4-inch audio jacks which connect to your keyboard or your electric guitar. So now it's put together, and it kind of looks like a fully functional enclosure, and everything is put together well. Questions? Nazir.
What do you mean by different formats of instruments going through? So like, what's the difference between a signal going from an electric guitar or your computer?
So, for example, if you're talking about a computer signal, or this is called a line level signal. So this is something that would come out of a headphone jack or an instrument like a keyboard, where they produce their own electrical signals that are kind of powerful in comparison to other instruments. So it's like easily, because they're very loud, so this doesn't have a hard time hearing it. An instrument like guitar, though, is kind of a weak signal because most guitars don't have their own power source. So the signal is entirely generated just from the energy of the guitar strings vibrating back and forth. So that's a very weak signal. And there's also something called impedance, which is kind of a measure of how hard the signal pushes. It's slightly different from voltage, but that also affects sound quality. So if you don't have a circuit that's designed to work with high impedance signals like a guitar, then you can lose a lot of sound quality and it sounds bad. So my PCB kind of fixes all of that and makes it workable. Brian?
If you had more time to work on this project, what would you add next? What would you change?
I would probably add more functionality. So I 3D printed this in the last week, and since it's already 3D printed, there's not like extra hardware I can add because it's all assembled, and I'd have to reprint everything. But I could do stuff like I can maybe add more inputs and more outputs so you can connect multiple instruments at once. I could also make it, so right now I have 3 buttons and 3 knobs, so you can do 3 different effects at once. But in theory, I could just do more depending on like how complex they are and how much processing power they take on the microcontroller. Right.
Is there any delay with using
like latency?
Yeah.
So I've tested a few different things. The latency has been really low, from what I can tell. It's kind of hard to tell because I'm like using this whole whack setup with my computer. But I tried with an actual synth one day that Nazir brought in, and it sounded pretty good. I think there's probably only around, I'd estimate 20 milliseconds of latency, but that would depend on the effects I'm using.
Let's get one of the students last.
Greg?
Where do you find and upload the effects? Or how do you add them to your device? Do you create them?
So there's a few things you can do. What I did is there's this library for the TNC called the TNC Audio Library, and they have their own kind of pre-built effects, like functions that you would call in your program and put in your virtual signal chain that will automatically work, and you can set that up pretty easily. But there's also options where you can like program your own effects. You can, one example is something called the Wave Shaper block in the TNC Audio Library. And what it basically does is you can have a table, like a big table, lookup table that says if the audio signal is like at this level, because you know like a signal is a kind of sine wave, so you can kind of make a table that maps that sine wave to some other shape that will modify the sound in different ways. So that's one way you can do a custom effect.
Why did you choose this to be your project?
So I play electric guitar, and I own a couple of units that would be like traditionally the analog units. So that would be something called guitar pedals, and they might be distortion or delay or reverb, whatever. But they're standalone units, and once you buy it, like that's cool. That's it. That's all it does because it's an actual physical circuit. But it's all digital. It's all in software. So if I want something else, I can just program that and change what it does. So it's kind of customizable. Again.
How much did it cost you?
So how much it costs kind of depends on what you want to do. I would say at the minimum it would cost you like maybe $50. You could get a TNC for 30, and then audio connectors you can kind of jerry rig. But I spent more on stuff like all these knobs, these buttons. I had like, this is connected to a battery. I have like an extra jack here. So I added a bunch of stuff for power delivery to make it like a standalone unit that doesn't require external power. Aside from like a cord, but you don't need to like plug it into your computer to run stuff like that. So that kind of drove the project cost up a little bit, but you can make this for much cheaper. Yeah.
Why did you choose the TNC? And also, what's the resolution of the ADC and D8 jack?
So I use the TNC because it is way more powerful and because it has this built-in audio library that's designed for processing. So right now I'm using the TNC compared to the Arduino is orders of magnitude more powerful. The TNC runs, you can overclock it up to a full gigahertz, where the Arduino is, I don't know, it's like 44 megahertz or something, I can't remember. But it's really low. ESP32 might also work, but in the past I've had issues with ESP32 audio. And the TNC also comes with, you can buy this adapter board, which will convert the analog signal into a digital signal. It's called the TNC Audio Shield, and you mentioned it has that DAC. It's running at, I think, 44.1 kilohertz, so sample rate, so whatever the standard is. So the audio is high quality, and I believe it's 24-bit audio.
Oh, wow.
So yeah, and I monitored the usage. I'm using like 10% of the CPU right now. Actually underclocked it to cool it more, so it's really powerful.
Yeah.
Other questions?
Cool.